Hi, good afternoon, everyone. Hopefully the A Math paper 1 for O-levels, for the O-level students, it was okay. I heard some pretty polar opinions about it. Some found it easy, some found it hard. Nevertheless, even if the topic came out in paper 1 already, I still hope that some of the topics in this paper 2 for mathematicals will come out for the O-level paper so that you guys are familiar with it. So all the best for tomorrow afternoon, and I'll try to get this up. Well, I'm recording it right now. Okay. So once again, I said that the paper mathematicals is usually not too difficult. So let's have a look at this. We are given that y is 4x sine 2x, find dy dx. Okay, for this we use product rule, of course. So we keep the 4x first, and then differentiate sine 2x to get 2 cosine 2x, plus we now keep the sine 2x and differentiate 4x, and we will get, well, we can factor out the 4, right? And of course you will see that you'll get the 2x cosine 2x plus the sine 2x. So quite simple. Given that x is increasing at 2 over 5 radians per second, find the rate of change of y when x is pi over 2. Okay, so we are given, so this is interpretation here that dx dt is 2 over 5. Okay, so dy dt will be, as per usual, dy dx times dx dt, and you will just get 8 over 5. Oops, I need a bit more space for this. So this is 8 over 5, 2x, oh no, is it 2x? Yes, 2x cosine 2x plus sine 2x when x equals to pi over 2, dy dt is 8 over 5, okay? Cosine pi is -1, so negative pi, and then sine pi is 0. So this is just -8 pi over 5 radians per second. So y is actually decreasing in this point in time. Okay. Question 2. Show that the derivative of ln x squared over x is this. Okay. Now you can realize that actually this is x squared is actually 2 ln x divided by x. Okay, we'll use the quotient rule. So x squared at the bottom. Keep the x first. Differentiate 2 ln x, you'll get 2 over x. Then minus, keep the 2 ln x, and then differentiate x to get 1. Okay, simplify this. You get, well, you just get the result 2 minus 2 ln x divided by x squared. Hence, evaluate the following integral. Okay, so the integral from 1 to e of 2 ln x over x squared dx. Now, hopefully you realize that this is the integral from 1 to e of 2 minus 2 ln x, or rather minus 2 minus 2 ln x divided by x squared dx. Actually, no, won't put the dx first. If I put the negative in, I'll get 2 ln x minus 2, but I want 2 ln x only, so I add back the 2 over x squared dx. And this will be the integral that we solve. We know that integrating this will give us ln x squared over x. So I get, what do I get when I integrate 2 over x squared? I will get -2 over x, right? So I could actually factor out the negative, and I will get ln x squared over x plus 2 over x, and this goes from 1 to e. Now if I put e into here, I will get 2 over e plus 2 over e. So 4 over e. Then if I put 1, this will be 0. and I will get over here minus 2. Okay, so this is 2 minus 4 over e. Yeah. Okay. Find the coefficient of x cubed in the following expansion. For this, we're going to need to consider the well, actually, we can just use the term in the fourth term, right? So T4 is, you keep the 2, rather no, you keep 6, you put 6, choose 3. You have 6, choose 3. Then you take the 2, then 6 power negative 3, or rather 6 minus 3, and negative 3x cubed. Okay, then you can evaluate this. 6 choose 3 is 20, so minus 4320 x cubed, coefficient of x cubed equals to negative 4320. Write down the first 3 terms in this binomial expansion. Okay, so this is 1 plus 8 choose 1 is just 8. Anything choose 1 is just itself. So you get 8ax. 8 choose 2 is, what's 8 choose 2 again? 8 choose 2 is 28. So you get 28a squared x squared. Okay. And 1 we don't need to worry about because 1 to the power of anything is just 1. Given that this binomial expansion, or rather not just this normal expansion, is this, find the value of a and b. Okay, so I have, so let's expand 1 minus 3x squared actually. So I'll get 1 minus 6x plus 9x squared times 1 plus 8ax plus 28ax squared x squared. So I only need to expand these terms to give me all the terms in the constant x and x squared. The constant is just 1. Then for the coefficient of x, I need 8a minus 6. Then how do I get the coefficient in x squared? I need 9, and I need 9 plus 28a squared, so 28a squared plus 9. Actually I should highlight, maybe I should highlight which ones will get together. So I will get perhaps this one together, and the other x squared will be this one, and let's not forget this one also. Okay, so that is what I'm actually trying to do. So I'll get 28. Actually, I realized that this is a quadratic expression, so let me write it that way. 28a squared minus 48a plus 9 x squared. Okay, so we have 8a minus 6, okay, and then plus dot dot dot. Actually, I should write technically, but we don't need any more terms. So 8a minus 6 is 10, so one can find the value of a. A is equal to 2. Then b equals to, well, you can find what that is. It's 25. Okay. Geometry proof. In this diagram, with AD is tangent to the circle, BCD is a straight line. Okay. Proof that AHD and BKD are similar, so that will be okay, so KD bisects angle ADC, so these two are the same, and alternate segment theorem. Okay, so angle HDA equals to angle, remember to write a thing correspondingly, KDB. KD bisects angle ADC, and angle HAD equals to angle KBD by the alternate segment theorem. So you have by AA, right? by the AA similarity test, two angles are equal. HD times BD equals KD times AD. Whenever you see sides in a geometry proof, actually I think geometry proof already came out for the O-level paper 1, but never mind, we'll still go through. So whenever you see multiplication of side ratios, it's always to do with similar triangles. So this one is quite simple, I think, because you see that I have HD on this side and I have AD on this side, whereas I have BD and KD on the other side. So it seems that I should compare HD and AD together. So HD over AD equals to, you will realize that this is the same as KD over BD by writing the corresponding sides of a similar triangle. Then expanding this will give you the result. HD times BD equals to KD times AD. Quite simple. Triangle AHK is isosceles. So, well, we proved that these two must be the same. Actually, no, we don't even need that. It's quite simple. AHK is the sum of HAD and HDA. Okay. So let's write down angle H. Wait, what angle is this? Oh, AHK. Okay. AHK. Angle AHK equals to angle HAD plus HDA, right? Because of sum of two exterior angles equals to the interior angle, right? Or rather, no, as sum of two interior angles, exterior angle, sorry. Okay, and then for the same reason, I can write AKH is KDB plus KBD. Okay. What angle is this? AKH. Okay. AKH, this equals to angle KBD plus angle KDB. Same reason, sum of two interior angles equals to exterior angle. Therefore, angle AHK equals angle AKH, base angle of isosceles triangle. Therefore, triangle AHK is isosceles. Okay. Show that cosecant times secant is this. Okay. Now tangent and cotangent, usually these are the ones that I can expand. So I think I will start from the right hand side. And let me write it this way. Tangent, cotangent is 1 over tangent, right? So this is tangent x. Tangent square x plus 1 divided by tangent x. Combine it into a single fraction in terms of tangent x first. The numerator is secant x. So one gets secant square x, sorry. The numerator is secant square x. One can multiply the top and bottom by cosine. So we get secant square x times cosine square x divided by tangent x times cosine square x. And let me write tangent x as sine x over cosine x, so that's a bit more explicit. This gives me 1 over, you will notice that this is sine, you will get sine x cosine x. Okay? And this is actually, I think you can start to see where the thing is coming already. Because this is 1 over sine x times 1 over cosine x, which is cosecant x secant x, which is the left hand side. Yep. Okay. Hence solve the following equation. Okay, so they want us to solve the equation So this is equivalent to the equation tangent x plus cotangent x equals to 2. Sorry. So let's see what happens there. So tangent square x plus 1 divided by tangent x. Once again, this is equals to 2. And this is actually a quadratic equation. So I get tangent square x minus 2 tangent x plus 1 equals to 0. And here's the fun part. This is a perfect square. Tangent x minus 1 square equals to 0. Therefore, tangent x equals to 1. And we are solving for 0 to 3 pi. Luckily, you know that tangent x has a special angle for 1. So you can write down all the angles. So pi over 4, not 3 pi over 4, sorry. 5 pi over 4, and 9 pi over 4. Okay? I think it's only 3 marks. I don't think you need to show like the basic angle stuff because it's only 3 marks. It's an exact answer, so you can just write down all the values. Question 6, express the following in partial fractions. Okay, so this is a very basic case. We don't even need to do any other factorization. We just take it as is. 7x plus 4. So this is the case. Partial fractions also already came out of the O-level paper, but never mind. And I think the O-level one was actually harder. But when you have this case, you will get a linear term divided by x minus 2, and then add the bx plus c, divide by x squared plus 5. And I'm going to multiply everything. Unfortunately, this is not a linear denominator case, so we cannot use the cover-up rule. We need to solve it the good old-fashioned way. 7x plus 4 x minus 2 and alright, no, we don't need to multiply this, sorry. 7x plus 4 is just equals to multiply both sides by 7x plus 4 equals to ax squared plus 5 plus bx plus c times x minus 2. Okay, so we solve for, let's solve for a first. So to solve for a, let x equals to 2, so that this is 0 and the whole thing over there is 0. You will get 18 equals to 9a, which implies that a is 2. To find c, we can let x be 0, and then we will get 4 equals to 10 plus, or minus 2c rather. 10 minus 2c, which implies that c is 3. Finally, let x be anything else so that we can find b. I'll just choose a nice value like 1. I'll get 11 equals to 12 plus b plus 3 times minus 1. So actually minus b plus 3. And this implies that b is negative 2. I believe so. No, it's actually 4. Wait. Yeah, 4. Negative 4. Huh? Wait, no. b plus 3 is 1. Oh, b is negative 2. Okay, sorry. b is negative 2. Negative 2 plus 3 is 1. 12 minus 1 is 11. Okay, so you can write down the answer. 7x plus 4 divided by x minus 2, x squared plus 5. This is 2 over x minus 2. Now we have a minus 2, so you cannot write the minus on the top. So what you need to do is you need to write this like this, minus 2x minus 3. Okay? X squared plus 5. Yeah. Okay? That's cool. Express this in the form ax plus b squared plus c. I believe this also came out for the O-level paper already, but good practice nonetheless. So I always tell myself when I complete the square, always make the coefficient 1 first so that you don't screw things up for yourself. In fact, they are kind of helping you with the a there. So what I'm going to do is write this as 2x squared minus 6x plus 7. I'm going to write this in the form 2x squared minus 3x plus 7 over 2. And then this is 2. This is x minus 3 over 2 squared. Then you get the 9 over 4 out. So seven over 2 minus 9 over 4. And you will get plus 5 over 4. So you get 2 x minus 3 over 2 square plus 5 over 2. Okay. So A is 2, B is negative 3 over 2, and C is 5 over 2. Okay. Why this curve will not intersect? So for XER, for all the real values, x minus 3 over 2 square greater than or equals to 0. Therefore, 2x squared minus 6x plus 7 is greater than or equals to 5 over 2, which is greater than 2, so no intersection. Okay? By using suitable substitution, solve the following equation. Okay. We let u equals to log 3x. Now, log x3 is always the reciprocal of log 3x, but the problem here is that we have an 81. Luckily, 81 is 3 to the power of 4. So bring down the 4 so that we get half u equals to 3 plus 8 over u. And then form the quadratic equation from there. So 1 multiplies both sides by 2u to get u squared minus 6u minus... Wait, multiply by 2u, right? So what, 16? Equals to 0. Let me just check something here. Yeah, this looks right. Okay. So this factorizes to u minus 8u plus 2, I think, equals 0. So u equals 8 or u is negative 2. But remember, u is log 3x. Log 3x equals to 8 or log 3x equals to negative 2. Now note that logs can be negative, not like they're not indices, so don't reject. Logs can be negative. And then x is 3 to the power of 8. So what's 3 to the power of 8? It's 6,561, or x equals to 1 over 9. Okay. Solve the following simultaneous equations. Okay, for this we usually like to convert the thing into a linear system. So 4x divided by 8y. So note that this is the same as saying 2 to the power of 2x minus 3y equals to 2 to the power of 5, which implies that 2x minus 3y is 5. And we have the system log 2. We can combine the logs together. We get x over y plus 1 equals to 1, which implies that x over y plus 1 is 2, and therefore x equals to 2y plus 2. Okay, so we will use this form. So we get 2 times 2y plus 2 minus 3y. This is equals to, okay, this is equals to 5. This is 4y plus 4 minus 3y, so y plus 4 is 5, so therefore y equals to 1, and you can find that x is 4. Yeah, okay. Alright, I'll take a quick break here and we'll go through the rest of the questions in a bit. Alright, we're back. So, coordinate geometry. Show that the coordinates of A is -1, -2, Okay, so this is by using vectors. So we use the fact that BA is equals to DC, or no, CD rather, and we write down the vector. And this is the vector, I think, -6 and -9. So OA is BA minus BO, which is -6. Now BA minus BO is the same as plus OB, so we can write -1, and -9 plus 7 is -2. So therefore A equals to -1, -2. Okay. Find the equations of lines CE and DA. Okay, what is E? Perpendicular from C to AB meets DA extended at the point E. Okay, so let's draw that. What would that look like? Let's extend DA first. Okay. So E will be somewhere here. And this is the, yeah, okay. What is the equation of CE? So for the equation of CE, we need the gradient of AB. Which is 7 plus 2, 5 plus 1. 7 plus 2, 5 plus 1 equals to 3/2. What is the gradient? Okay, so the gradient of CE will be is a perpendicular line, so gradient will be negative reciprocal. Equals -2/3. We have the coordinates of C, so y minus 6 is -2/3 x, so this is just y equals -2/3x plus 6. So this is equation CE. And what is the equation of DA? The equation of DA is, we can find the gradient of DA. So gradient of dA will be -2 plus 3 minus 1 plus 6. Okay. So -2 plus 3 minus 1 plus 6, which is 1/5. Oh wait, huh? Oh wait, yeah, this is correct. Okay, so equation dA, we have the point -1, -2. So y plus 1 or y plus 2 is 1/5 x plus 1. So y equals to y minus 2, y plus 2 equals to 1/5 x plus 1, which implies y equals to 1/5 x, then 1/5, so minus 9/5. Okay, find the coordinates of E. Hence, okay, so that is just equating CE and DA, right? So we have y equals to -2/3 x plus 6, and y equals to 1/5 x minus 9/5. Okay, so solve these simultaneous equations. So one gets 1/5 plus 2/3, which is 13/15. x equals to 39/5. So one can find the value of x from here. X is I think 9. And what is y? Y is actually 0. Yeah. So it actually lies on the x-axis. So E equals to 90. And what is the ratio dA to AE? dA is, so we write down the vectors dA and AE. dA equals to 5 and 1, right? AE is 10 and 2 equals 2 dA. So therefore, dA to AE is 1:2. Okay. Name the special quadrilateral BCDE. Explain clearly the reasons. So BCDE is a special quadrilateral apparently. It seems to be a trapezium because BC and DE are parallel. So this one is just BC is parallel to DE. That's it. Find the area of quadrilateral. Okay, shoelace. Or you can use yeah. I think for O-level syllabus, the most relevant formula is shoelace. So let me just write down the coordinates so that I have a bit of an easier time. Okay. So area of this quadrilateral will be used the shoelace method. 0, 6 minus 6, 3 minus 3, 9, 0, 5, 7, 0, 6. Okay. So what do we get? Okay. So we get half, there's a lot of zeros, so we get 63 plus 30 plus 36 plus 27. Wow, everything's plus. $78. Okay. Area under curve. Find the equation of tangent at P. Okay. The normal to the curve at P is parallel to this, so that is to say the gradient is -2 at the normal. So one finds dy dx equals to, well, the 3 will be gone. So you will get, when you differentiate this, you should get 8 over 2x minus 5 squared. Oops. Okay. So write gradient of, just explain a bit, at P equals to -2. This implies gradient of tangent is +1/2. Okay. So we can now let dy dx be half, which means that 2x minus 5 squared equals to 16. Then of course you can solve for x. X equals to half of 5 plus minus 4. X equals to half, or x equals to 9/2. But one of these should be rejected, I think, because P must be greater than 3.167. one has that value of x, one can find the value of y. Y equals to 3 minus 4 over 2x minus 5. So this is 3 over 4 over minus 9 minus 5. So this is just 2. So therefore we have tangent at P. So y minus y1 equals to m x minus x1. Y equals to half x plus minus quarter. Is it? I think so. Yeah, seems to be it. Okay, find the area of the shaded region RPQ. Okay, so we take the area under the curve and then subtract the line. How about we do line minus curve actually? That might be helpful also. So Q is, what is the coordinate of Q actually? So one takes note that Q is when this is 0, so this will be 2, 0. Oh no, half 0. Okay. Now we try to find the area. So line minus curve. But the problem is, actually we can use triangle because the curve here is not always going to be counted. 3.167. By the way, it's not actually 3.167, it's actually 19 over 3. So I can find the exact area. Though the fact that they give you 3.167 means they can probably leave your answer in 3SF. So triangle is a triangle of triangle, this is F and P is 9 over 2. Triangle PFQ minus the integral from 19 over 6 to 9 over 2 of 3 minus 4 over 2x minus 5 dx. Now the length of PQ, I think the 9 over 2 minus half, so that's half times base times height half. The y was 2, I think. Yeah, the y was 2, so half 4, 2 minus, okay, so integrate this, you get 3x minus 2 ln mod 2x minus 5, going from 19 over 6 to 9 over 2. We'll get 4 minus 27 over 2 minus 2 ln 4 minus 19 over 2 plus 2 ln 38 over 6. Okay, the 19 over 3 minus 5 is 4 over 3. Okay, and this is 8, so you get a 4 over here. No wait, no, there's some, sorry, this is a negative 4. No. 27 over 2 minus 19 over 2 is 4 exactly, so that is just that. And this is just going to be minus of 2 ln, okay, so 4 over 3 minus 4, so there's actually 2 ln 1 over 3. So this is exactly 2 ln 3. And this is 2.20 to 3SF. Not sure why they give not sure why they asked us to round to 3SF, because actually gives a very, very nice value if you get the exact answer, 2 ln 3 exactly. Okay, we have this. Let me close my notepad first. Okay, so we have, okay, this looks like our formula. So perimeter, so BC, so take note that this is also theta. BC equals to 12 sine theta. CD is 7 cosine theta. AC is 12 cosine theta. And EC is 7 sine theta. Okay, then from here you can find what P is. P equals to AB plus BC plus CD plus DE plus EA, which is AC minus AE. EC, rather. Okay, which should give you the thing that you want. AB is 12, so you get 19. AB plus DE is 19. BC being 12 sine theta, so 12 sine theta plus CD, which is 7 cosine theta, plus 12 cosine theta minus 7 sine theta. This is 19 plus 7 plus 12 is 19 cosine theta. And then the 12 minus 7 is 5, so plus 5 sine theta. Okay, express P in this form. Okay, so P, obviously the 19 we will keep on the outside, plus, okay, so R cosine theta minus alpha. So R is square root 19 square plus 5 square equals to, well, you can keep the exact answer, it's 386. Sorry, just keep this first. Then alpha is tangent inverse of 5/19. Which you can write in degrees. Okay, so it's degrees. So this is 14.744 degree. Okay. So you can express P in that form. Find the maximum value of P. Okay, the maximum value of P is just square root 386. Equals 19.6 3SF. And the alpha value will be 14.7. Okay. So theta equals to 14.7, yeah. Because the maximum value of a cosine function is when the input is equivalent to 0. So that will be 14.7 degrees on dp. Find the value of theta, of which p is 32. So we want, oh wait, no, it's 19 plus root 386. I just realized. Sorry about that. So it's 38.6. Okay, find the value of theta, of which p is 32. So 32 is 32 minus 19. Okay. So therefore one has cosine theta minus alpha being equals to 13 over root 386. Okay. So because theta can be first or second, theta can be like for cosine inverse to be positive, you can have the first or second quadrant. So this is actually plus minus theta minus alpha can be 48.572 degrees. Okay. So either theta equals to either theta is 63.3 degrees, or if you take the negative case, you will get negative theta minus alpha. So you will get negative 33.8 degrees, which doesn't make sense. So you get theta is just 63.3. So take this as the answer, 63.3. Okay. Yep. Okay, give me one more break. This should be the linear law should be the last question, and it looks like plotting, so that will take a while. Okay, so the last question is linear law. We have this experiment to find the population of insects. Okay, so for this part, we need to plot ln y against x. Okay, I already wrote down the values here for you guys. You can check for yourself. And I have the table on me on the other side of the screen also. So vertical starts from 6.2. Okay. So they give us an instruction to start the axis from 6.2. And we have 2, 4, 6, 8, 10, right? So let's declare this to be our starting line. This will be x. Okay, so this is 2, 4, 6, 8, and 10. Okay, and then we have a vertical axis, starts from 6.2, 6.4, 6, 8, 0, 2, 4. Okay, we should have enough space. So this is 7. Very difficult to draw a straight line. Okay. Oops. Okay, so this is 7, and my highest number is 8.04, so okay, seems about perfect. Oops. I'll take care of that in a bit. No. So let's mark the numbers. 6.2, 6.4, 6.6, 6.8, 7.0. Okay, hopefully you guys are faster than me at this. 7.2, 7.4, oops, 7.6, 7.8, 8.0. Okay, this is ln y. Okay, so at 2 we have 6.93, so this is 6.9, so 6.92, so 6.93 is here. You can always map to half the smallest division. 7.20 is here. 7.47 is here. 7.76 is here. Oops, a bit off. Okay, and then 8.04 should be here. Okay, so now you have a line. Okay, what does this line gradient look like? Oh, I'm shifting my tablet. Oops. No. I will probably get a picture of this. Maybe I don't need to. I'll just do it one at a time. Okay, slowly. Okay, get the straight line down. Oops. Okay. Now extend the line a little bit so that we get an intercept. Okay. Estimate the value of k and p. Okay. So what is actually happening? So if I plot this, I get ln y equals to, if I take s, I get ln k plus 1/3 ln px. This is actually what is happening when I take the ln on both sides. So the gradient of the curve is actually 1/3 ln p. So let's pick some points. Pick one that lies on the... So when you calculate gradient, always pick a point that lies on the grid and between the first and second point. So let's pick this. This point is 6. Oh no, this is 2.2, I think. 2.2 and 6.96. Then your second gradient point should lie within the fourth to last point. So you get 9.6, 8.00. Okay. Okay, from graph, y equals to, alright, or rather 1/3 ln p. 1/3 ln P is 8 minus 6.96 divided by 9.6 plus 2.2. From here you get the value of P. You get P equals to 1.52 3SF. And then you can also find what is K. I'll write down what I got 1.5244, but your answer might differ. And what is K? K depends on the value that you chose. So I'll use the fixed point of 2 and 6.93 for this. So I'll get okay. One will find that their K is 772 to 3SF. What Y value did I even get? That's like 6.67. Oops. Which gives me a surprisingly close answer. I get 788 by that. But yeah, it depends on how you draw your sketch, and your answer is going to vary a lot. Use your graph to estimate number of weeks needed for the population of the insect to be doubled. Okay. For the population to double, the start of the experiment seems to have so ln, what is twice of 772? Then you take ln of this, you will get 7.34. So draw the line y equals 7.34 on the graph, so that will be here. And our estimate tells us this is 5.2. Okay. So time taken. So this is X weeks, so it takes 5.2 weeks. Need 5.2 weeks. Or maybe just 5 weeks, I don't know. 5 or 6 weeks, depending on how you drew your graph, but I got 5.2. Explain why you cannot use the modifiers from the start of the experiment. Limitations in the environment, right? So this is just a bit of common sense. This is the kind of question. Okay, yeah. So that will be it for Methodist Girls Paper 2. All the best to all the O-level students taking the Paper 2 tomorrow afternoon. And my next video will be the Hwa Chong Paper 1 questions 1 through 7. So stay tuned for that, and I'll see you guys next time.